Well, I'd like to welcome you all to an unusual sambaXP year. And I'd also like to thank you guys for your patience as we've dealt with these unusual challenges. But it's also been a very exciting year for me. And I just got done, obviously, going through some of the talks from yesterday and was very pleased with some of the progress in Samba. But what I want to talk about here is some of the progress in Linux, a lot of it in the kernel, and how that'll help and make it easier for us to access Samba going forward, access the cloud going forward, access SMB servers going forward. And I'm really excited also about all the contributions from many others to make this, this SMB3 protocol, this sort of the common denominator to access everything in the cloud, in NAS devices, and small devices, and large devices, and clusters. So I'm going to talk a little bit about the general status of Linux and Linux file systems, and then go more specifically into the network file system, SMB3, talk about the new kernel server somewhat. That's been very exciting. And also the SMB kernel client and its related tools and how that can improve your life. So to give you some perspective here, let's focus on where we were last year. Last year, Linus has a habit of using clever names. And last year we had golden lions, which sounds a little more, I don't know, sounded more dignified to me than a kleptomaniac octopus, where we are today, but that's what they call it. So a year ago we were at the 5.2, we had just released the 5.1 kernel a few weeks earlier. And next week we should be releasing the 5.7 kernel. This has been a very exciting time. And there's a lot of discussions. The Samba community is not necessarily always plugged into the Linux file system community and some of the stuff going on. There's been some quite interesting changes going on in the Linux file system layer. I think many of you are familiar with IOU ring because Samba was recently taking advantage of that and found various bugs. And it's been a very exciting time for Samba, dealing with better async I/O.
Can I interrupt you just for a second? Myro, your talk is up at track 1. You are at the wrong track. Thank you. Okay.
Am I on the right track or wrong track?
No, you are on the right track. Myro was on the wrong track. Thank you.
Well, I tell you what, as a speaker, I sympathize.
Yes, it's not quite great.
It's an easy mistake to make, but at least I don't have kids that have run across in pajamas in the middle of the talk. Like I think you guys saw the Microsoft Build news stories yesterday where the poor guy's presenting and his kid runs across the screen. Okay, so I want to kind of make you guys aware of some of the big discussions that are driving what we think about in Linux. I think all of you are familiar with containers and virtualization, aware of that, but some of you might not be aware of this this incredible improvements we're getting with async I/O. And yet at the same time, we have areas where Linux is incredibly primitive. I gave a talk at the File System Summit last year in Puerto Rico, the Linux File System Summit, about the Linux copy problem, about how our tools are really quite poor. We own some of them in Samba.org in some sense, right, because we have rsync hosted on Samba.org. But the CP command and rsync and DD and many other tools on Linux, none of them are as functional as robocopy on Windows, for example. So there are areas where we have real improvements that need to be made in the file system layer. But we also have to be aware that the whole ecosystem is changing. It's very different. Well, in many cases, we save presentations into the cloud, right? We mount to Azure. Very long latencies, potentially, right? Saving something that is being sent 5,000 miles away. Versus things like RDMA, SMA direct, where the latencies are almost non-existent. They're very, very short. I also want to leave you with something, a thought. If the kernel is 5.0 or later, you're good. There were huge changes that I personally like in the 5.0 kernel and later, but we were allowed, according to Linus, to make up our own reason for why 5.0 marks something new and reborn. And for me, it's 5.0 and later, the SMB3 client really gets a heck of a lot better. And it's been improving very rapidly since that point. This has been a fantastic year. I also want to call out a lot of the, we don't get to meet in person and see some of these developers, but here's a mix of some of the Microsoft developers and a lot of the Samba team here. So last fall, here's the IO lab in Redmond. A lot of the Samba team developers. It's amazing the amount of work that this team gets done, not just on the server, not just on the client, but on the whole ecosystem. So let's step back a little bit and look at how this fits into the overall Linux story. Last year, I just measured this yesterday, 5,319 kernel change sets. File systems are almost 7% of the overall changes to the kernel. Now, obviously, the overall changes are dominated by device drivers, but these are the most watched areas of the kernel, file systems. And the kernel itself is huge. So the kernel is 19 million lines of code. Now, that's 5 or 6 times bigger than Samba. It's enormous. There are about 60 a little over 60 file systems, but 6 of them dominate the activity. And of course, that includes us, right? The SMB driver, cifs.ko. I think many of you are familiar with XFS, but I think many of you might not have realized that cifs, the SMB driver, is one of the most active file systems in Linux. So last year, there are 322 change sets in the kernel alone, not counting all the utilities. And it's up to almost 55,000 lines of code. And that doesn't include the new kernel server, which I'll talk about in a little bit. But for those trivia fans among you, and if you're curious what file systems got the most changes, take a look at BTRFS. It had almost as many as the overall file system mapping layer. And by the way, the file system mapping layer, this is something that Samba ought to be very aware of, got more changes by far than usual. And what that means is there are lots of file system features, new APIs, improvements to that we need to leverage in Samba. Not just that new mount API, not just xstat, statfs that we talked about before. There was a lot of work in the mapping layer this past year. Some of it having to do with IOU ring, of course, but it was spread quite broadly. So the cifs client, since about the 4.18 kernel, maybe 2.5 years ago, the activity has exploded. It's doubled or more, and in general, NFS activity, especially the NFS server, has gone down. And it's kind of fun to look and compare Samba with 5,000 change sets a year, over 1,000 in the file server component. Just compare that with the 1% of the size NFS server, right? Samba's 3.4 million lines of code. NFS server is tiny. It's fascinating how much more functional, how much broader what we do here in Samba is than other cluster protocols and network protocols. Okay, let's talk about the most exciting thing, I think, for a lot of people. We have this new kernel server to experiment with. We can get, there's cases where it's useful because its footprint is smaller. It's cases it's useful because it allows us to test things that are harder to test against Samba. And sometimes it's useful just to have a comparison point on Linux to measure how Samba is doing in comparison to something more objective. So the kernel server is already up to almost 25,000 lines of code. It originally was 25,000 change sets. Namjay and Sergey have condensed it down to a small set of 5, and it's currently being evaluated and tested before we request its merge to Linux Next. It also has a set of user space tools that I mentioned here as well. And I'll get into a little more detail on that. Okay, so let's talk a little bit about why our job is tough. The Samba guys writing the Samba VFS modules, the stuff I do in the kernel. The Linux API keeps evolving. Take a look at these features just added in the last year. IOU ring, these new syscalls. And Samba needs to take advantage of these. And why do we need this? Well, we want to make this the most secure way. Remember the talk we just had from William Brown, right, about security. We want to make this the most secure way to access file data, whether that data is in the cloud or whether that's on premises, wherever it is. And we want to make sure that it's easy, right? We want to make this transparent so the app doesn't even know it's running on an SMB mount. And we, of course, have to be responsive. There was if you've dealt with some of you guys like Tom Talpe and others have dealt with NFS RFCs in the past, they can sometimes take more than 5 years to get through. We can't wait that long. Some of these changes are going to have to be driven in the protocol much faster. And we have that opportunity here with SMB3. Events like this help a lot. Events like the Storage Developer Conference that we had back in February in Tel Aviv and last fall. The SMB test events we have regularly. Let's talk about some of the things, just to refresh your memory, that were fun last year that we talked about. Snapshot support. People take this for granted, but like my presentation, if I screwed up a version of it, I can go back to the snapshot. I can go back to an earlier snapshot and look at last month's version. Here we have a picture, right, of looking at 3 versions of the same directory, mounted to separate places, but we can go see, very, very easily the changes that were made between snapshots just by simply comparing the mount points. Snapshots are incredibly useful. We talked about this last time, but I like mentioning these things because people take them for granted. Or let's say DFS, right? Other protocols don't have something like this. Maybe AFS does, but this global namespace. So there was a great work done a little over a year ago by Paolo, and actually he's got a set of patches improving on this even more that I need to evaluate for the merge window next week. But think about the global namespace and just how incredibly useful that is to be able to support that in Linux and Windows and Macs. It's supported in the clients, it's supported in the servers. And we take it for granted where other protocols don't have something so powerful. So let's talk about the recent progress this year. So we have a new kernel server. I've been personally very, very excited about this. And I want to thank Namjay and Sergey and that team for some good work. You can refer to the wiki here that has some additional information. But if you look at this, if you look at the screenshot I took here, here is my local machine mounted to KSMBD, and here we have it. Right, we're looking at files that were created to a not Samba but to a Linux kernel server. And for some operations, the performance looks fantastic. But remember, this is experimental, and it's not meant to be a replacement for Samba. It's not meant to replace all the Samba use cases. So this module is called ksmbd.ko. We decided to, confusingly to some, but I think most people thought it was less confusing, we decided to name the directory cifsd. So the source directory has that evil 4-letter word that we're not supposed to use, cifs. Due to security issues, over the last 10 or 20 years, we've tried to remember to call things SMB3, not cifs, the old dialect. But to make the source code easier to find, we called the source directory cifsd. The module itself, though, has SMB in its name. And to distinguish it from Samba's SMBD, it has the letter K in front of it, so KSMBD. So when you see the processes running, the various processes that are launched, you won't get them confused with Samba's SMBD process. So if you want to see the code, there's the GitHub directory, and it's still experimental. Our goal right now, I'm just doing some sanity checking and build verification tests through the buildbot, the automated test infrastructure that Ronnie and Aurelian and Paolo put together to make sure that it does complete as many tests as we thought. It's up to about 100 tests that it's passing, and that's very promising news. And these tests will be running regularly before allowing the merges to be in, much like you have SMB torture run against Samba before check-ins go, and that process is still evolving. But I guess what I want to say in short is that it's ahead of where I expected it would be at this point for an experimental project, but it is still missing some features that Samba has, and we're not trying to replace Samba here. What I'm trying to do is make sure that Namjay and Sergey and that team do the right thing, and that we're adequately testing it and reviewing it, making sure it doesn't violate the coding guidelines and the check patch rules, and making sure we're not introducing strange security problems. And we're going to mirror this on samba.org, possibly into that cifsd.git git tree I mentioned there, so that we have the official version on samba.org and the developers version on the GitHub. Okay, so let's switch gears from the kernel server to what I love and what I'm working on, which is the kernel client. So one of the most interesting things that we've talked about on the kernel client has been we have many use cases. And one of the things that gets so confusing is that we have to support such a wide variety of cases. So for example, most people today, when they mount, they get a default owner, a default mode that are just specified on mount. We don't bother querying the ACL for anything. The server takes care of the permission checking, and we just report default POSIX users and POSIX mode. Works for a lot of cases. In a Kerberos scenario where every process potentially could be running with a different Kerberos ticket, a different Kerberos user, we have to be able to support these multi-user scenarios where the server is doing all the permission checking, and we have rich ACLs that are configured on the server that allow very granular permission checks. And the server's permission checks matter the most. We also have cases where we're more like NFS, where the server is more wide open, but the mode bits are evaluated on the client, and that's what's more important. So we need those mode bits, the POSIX mode bits, those very primitive, 777 permissions. Forget the server ACL. What we care about is those POSIX mode bits. That scenario, we call it mode from SID and ID from SID. The mode is opaque to the server, right? Samba, Azure, Windows doesn't care what those are. And following the way it was done with the Windows NFS server, it's stored in a special ACE with a special SID that is unenforced because it won't match any user. But embedded within that SID are the mode bits and the owner information. So we have these different scenarios. So, when you're creating a file or you're making a directory, you could have two choices, right? You could use the default owner, or you can get your ID from the SID. If you get your default owner, you can get your mode bits from SID, MFS there, or you could get it from the ACL, which is a best case mapping from the server-side ACL, or you can use the default. Similarly with ID for SID, the same choices. You can get your mode bits from this special SID. You can get your mode bits as a best case approximation of the ACL entries for every one user and group owner, or you can use a default. And this chart explains to you on create and make dir what you would see passed in, right? In one case, you have the owner is sent, the group is sent, and 4 ACEs are sent because you have this special SID and the user's permission, the group's permission, and everyone permission. In the cifsacl case, you have 3 ACEs sent. In the default ACL, you don't have to worry about it because it's the default ACL. So this gives you an idea on create what gets sent to the server and what you would expect to see in the Samba ACL for the 3 most common security scenarios. Once again, I want my default user and mode bits. That's default ACL. The second, I want the server-side ACL to be the best case approximation for the mode bits and the user. And so I'm going to be querying winbind to look up the UID of the SID. I'm going to be getting the mode bits by looking at what permissions the user, the group, and everyone has in the ACL. Or the third case, which I think is going to be one of the more common going forward, the permissions are evaluated on the client. The server has this opaque ACL entry that stores the mode bits, and that's the approach that the Windows NFS server uses. So I mention this because supporting these 3 scenarios well is important for many many Linux workloads. And as part of that has been addition of support of something called mode from SID. And here is an example on the right of, there are 4,096 mode bit combinations. So I wrote a tool that did all 4,096, and you can look on the right and you can see a subset of that, right? You can see the permissions, read, write, the set UID, et cetera, all the special, all 4,096 work with this. And obviously when you're trying to map them into an ACL, there's no way you can map all 4,096 cases into an SMB ACL. So this is useful for some workloads, and I mention it in some detail because I think it's going to open up some scenarios that some of you guys may care about. Okay, so here's the most exciting thing if you care about performance. Aurelian at SUSE did something called multichannel, And that allows you to spread I/O across multiple adapters. It's a huge performance win. The problem was that in 5.5 kernel, the I/O that was spread across did not include reads and writes. And changes were made in the 5, well, we're currently planning to merge them for the 5.8 kernel. And I did some testing to Azure. I did some testing to Windows. In some of my testing, I was getting 5 times better large I/O performance, even on in some one adapter cases when you have a very fast network interface. And the reason for that is it allows much better parallelism on the client and server. So with multi-channel, things like getting bottlenecked on CPU for decryption, encryption, signing, these things go away, right? Because now you've spread the I/O better on the receive path. You have more threads receiving stuff off the wire. Literally, I think with 8 or 16 channels, I was seeing 4 and 5 times better performance. And you know, it does decrease the amount of scaling you're getting with the number of channels, obviously, but this is an incredible performance win where we can see in some cases, well, easily see 2 to 3 times the performance gain. And depending on the server and the network interface, in my testing, I got as much as 5 times faster. This is incredibly helpful. And you know, I want to thank Aurelian at SUSE for some very good work here. And obviously, we need to performance optimize this and also make it easier to use. Right now, we have to specify the number of channels at mount time, which you know, we ought to be automatically determining. And as we integrate witness protocol, and I think you guys saw the presentation yesterday, some of you, that discussed the witness protocol work on the server. If we can integrate the witness protocol client into callouts, ioctls into the cifs driver, we're going to have a big advantage here because we'll be able to dynamically change the number of network adapters we use. So here's a trace of using multi-channel. And you know, this is just, if you look at the colors, you can see each color represents a different channel being used. And you know, you can obviously see why multi-channel can be helpful, right? You're spreading I/O across the network interfaces. And this can be useful even, as I was describing, even in a case where you only have one network adapter. So SMB3 is like a toolbox that's stuck in your garage and sloppy and messed up and got all things flowing all over and hard to find and hard to figure out. It's got incredible sets of features. One of them, and they can be incredibly useful, this little toolbox, right? One of the toolbox components there is compounding. We have the ability to combine things in SMB in ways, sometimes the Mac does maybe the best job among the clients of doing this, but Linux hadn't done much compounding at all until Ronnie decided to attack this. And over the last 1.5 to 2 years, I'd say the last 1.5 years, we've added support for compounding for a lot of common operations. But I mean, just the number of round trips matters, especially when you're mounting to the cloud, right? You have the long latencies. When I delete a file, using 60% fewer round trips matters. It's a lot faster. You know, doing a hard link, going from 8 to 3, even in 5.6, just going from 9 requests down to 7 requests, that's a big improvement. And basically all that's required here is we look scenario by scenario. Can we combine 2 operations into one, leverage compounding, reduce the number of round trips, and improve our performance? So we've done, as you can see, quite a few important scenarios here, but there's room for more. And as we see, the Mac is a great example of how it can help a client a lot. Also, remember one thing that's kind of fun about SMB, we support a lot of Linux features that other Linux file systems, network file systems don't support, which is kind of ironic. We already support, for example, FIE map, right? The ability to query the allocated ranges within a file. There are workloads that require this, right? The sparse file support and being able to query the allocated ranges. Obviously, if you're only reading file ranges that are allocated, you can improve performance a lot and use less space on disk. But here's an example of a tool, a test tool Ronnie wrote to demonstrate the use of sparse files and FIE map. And here's what it looks like on the wire, the query allocated ranges. Once again, SMB is an enormous toolkit supporting more stuff than anybody remembers, that any one person can know. But it's fun to implement these because it allows us to take advantage of Linux file system optional features that other file systems can't support. So here's an example program using sparse files that Ronnie put together. And for maybe after this talk, it might be fun for you guys to look at query allocated ranges and how this works. But it's a fun example of using sparse files and the kind of thing that allows SMB to be used for very advanced test cases. Well, one of the problems with workloads is most people don't know what their workload does. I can't tell you how many times at Microsoft, a customer problem might come in and the support person, the customer really has no idea what their app is doing, literally no idea what they're doing, right? Is it doing a lot of opens? Is it doing a lot of closes? So one of the things that's been fun is trying to trace that. And Linux has a dynamic tracing infrastructure that came out of the Berkeley packet filter called eBPF. And if you get a chance, please, please, please go on Brendan Gregg's website, look at some of the LWN articles on this, look at his book, look at some of the really nice coverage in the trade and the technical news on how BPF or eBPF works. Because doing heat graphs, doing dynamic tracing, doing things like complicated statistics by only enabling the trace points you need. This is now possible, and thanks to the Berkeley packet filter people over the last, let's say, 3 years, this has become possible. And about a year and a half ago, or maybe 2 years ago, the XFS, I guess it was just over 2 years ago, the XFS people talked me and Ronnie into doing this, and we're now up to 77 trace points, dynamic trace points, and these can be very useful for making it easy to figure out what's going on in Samba by looking at the client, figure out why the performance is a problem by looking at a specific set of requests. And we continue to add these as we debug problems. I was at the Storage Developer Conference in Israel. We were working at the test event there, working with Samba guys and working with some of the other vendors, and I had to add a trace point for a case. We weren't tracing close enough to understand a problem. But what I'm getting at here is this is incredibly helpful, this dynamic tracing, and it's a big enough topic that Brendan Gregg has written a book on it, but it's also easy enough to use that a beginner can do it. So it's something that I encourage all of you who are going to be doing server development or client development to explore in more detail if you haven't already. And it's something kind of unique to Linux. Okay, so one of the things that's great about sambaXP, and I miss at this event, this virtual event, is the hallway conversations. And we had these hallway conversations about GCM last year. Now, as you guys probably know, Samba supports SMB3 and SMB3 allows you to negotiate different encryption mechanisms. GCM is a lot faster. So as last year they put in GCM support in the server, what we have now is the ability on the client to support GCM. That was added in the 5.3 kernel. And why does this matter? This matters because it can more than double the write performance. So going, newer versions of Samba that support GCM, the 5.3 kernel in Linux that supports GCM, you can double write performance and 80% faster for read. Why? Because in most cases, these are encrypted connections, and encrypted connections benefit from the faster, more secure algorithm. So this is fantastic stuff. And it's a fun thing because the user doesn't have to do anything. You don't have to figure out the number of channels or do some weird mount option. It just works. So using the 5.3 kernel, using more current Samba that supports GCM, you'll see a huge performance win. So on this, take this laptop, for example. Large writes were 3 times faster, large reads were 2.5 times faster. This is a big deal for performance. If you combine that with multi-channel, remember I said in one of my tests, I got 5 times faster with 16 channels, even over a single network interface, admittedly a very fast network interface. I mean, imagine the performance gains we're talking about, an order of magnitude faster with these 2 sets of changes we're talking about. So Jeremy has a question that I'll come back to, and I want to not lose that thought. Jeremy had asked about quick support, and I'm going to talk about that in a slide coming up. So let's proceed on. Okay, so what about expanding how we think about what we use cifs for? What if we boot from cifs? Now this brings back fun memories because at IBM for a few years I was working on their network managed clients, and we were booting Windows and booting OS2 and things like that, and it was very easy to manage. Well, Palo added support for being able to boot Linux over an SMB mount. This will get even better, of course, with POSIX support. So what I'd like to get to here is where basically any scenario, whether we're talking about booting, and more recently we added support for swapping over SMB, we make sure we support all of the common features expected in a kind of a file system, and that requires, of course, other changes as well. And we'll get to those in later slides. So here's an example of what's needed for setting up booting cifs. You can come back to this slide later when they're posted. It doesn't default to the insecure SMB1 anymore. We were able to get it to boot on more recent, so that's an update to this slide. It doesn't support IPv6 yet, and that's something we'll come back to with hopefully future patches that fix that. But it's relatively easy to set up. Also, for those of you who care about security, sometimes it's useful to be able to know what host name the guy was trying to connect to. Maybe it's helpful for a load balancer, maybe debug tools. Just an easy change. Another example of the toolbox, right? If you can send it and it helps the server, why not? So if Samba wants to know what server we think we're trying to contact, it's in the net name context that's now sent from 5.3 kernels on. It's also sent in Windows clients. RDMA, SMB Direct is amazing. Now, Tom Talpi and others who are have been attending this virtually are more aware of some of the features here, but Longlead has done some great work. Starting in the 5.3 kernel, the testing improved. I mean, I was satisfied enough with the extra testing that was done on SMB Direct and some of the patches that came in that we no longer consider it experimental. It's solid enough for production from 5.3 on. And the performance gains for RDMA are amazing. So we talked a little bit about this last time, but just wanted to review. This was what was kind of going on last year at this time. This was the stuff that was just hot off the press last year, and was kind of a fun deja vu to think back on that. And then as we proceeded that summer, that sparse file support I talked about improved. And then as we proceeded to the storage developer conference, think around September last year, we had a fun improvement. Open, we cut 10% performance improvement, 10% performance improvement by a very simple change. Now, GCM we talked about, huge. Improvements for copy offload, another fantastic server feature, protocol feature. That SMB Direct, no longer experimental. These are great stuff. Going to 5.4, we talked about booting, but also that modefromsid parameter. There are cases where we don't want to worry about the ACL on the server. It's wide open. But we want those permissions evaluated sort of like NFS might, right? Those primitive POSIX mode bits are what matters. Also, in some cases, we need to improve performance by offloading decryption. Decryption can be very slow, right? Especially if the server doesn't support GCM. So we added a new mount parm that allowed any frame above a certain size to be offloaded to a different thread to allow more parallelism in processing responses, especially large reads. And also we've added a set of pass-through ioctls to let you do set infos, query infos, SMB FSCTLs across the wire from user space tools. So you can write much richer function, little Python scripts in user space that leverage SMB features. And I think what's important for a lot of us is, since we're running on encrypted connections, it can be super hard to debug. Now we have this SMB info keys that allows you to dump the Wireshark encryption keys if you're root, and dumping those keys allows you to look at your Wireshark trace. In 5.5, we added support for the BSD style whole file lock, the multi-channel. We can query attributes on close, which is another performance improvement, another example of where we can take advantage of little things in the SMB toolkit. On close, if you query attributes, now you have metadata, you can cache it for a second longer. So that close allowed you to refresh the data long enough so you can get better caching of metadata. And we were able to do a reader performance optimization as well in 5.5. In 5.6, we improved modefromsid even more, improved sparse file support. We had a request for backup and restore utilities to be able to set and get the DOS attribute. Well, we could already get, we could already get the DOS attributes in creation time, but we couldn't set them easily from user space because they're not POSIX things, right? Creation time you can sort of get at from Dave Howell's new API, but DOS attributes, owner info, creation time, this metadata, a lot of times backup tools need to be able to do this. So Boris put a patch in for allowing us to set it from user space tools. Reader, we did compounding to improve that. And then also we added support for change notify. The VFS itself in Linux, ironically, this is very strange. The change notify API was originally added for Samba, but it doesn't support Samba clients. It doesn't support SMB client or any network client because of the way the VFS is structured. But at least we can do an ioctl now if an application wants to wait on changes to a directory or file. And you know, we will work with the VFS maintainers to fix this in the long run so change notify can be supported on a network file system client. Once again, it's kind of ironic because that's the one case where it's useful. But today, Samba can leverage it on the server side to a local file system, but can't clients, network file system clients can't leverage change notify without using a special ioctl like we're using here. So in 5.7, we can now swap over SMB. We can now support POSIX reader. So this should come out next week. There's one remaining piece in the POSIX extensions. That one remaining piece is the query info. But a big performance improvement was also added for signed connections. We have much better parallelism by moving some mutexes that allow multiple requests to be sent at one time and avoid some serialization on the signing. In the 5.8 kernel, what you're going to see is this multi-channel performance improvement. And like I said, in one of my examples in tests, I was seeing 5x improvement with 16 channels. We'll also see support for IDs from SID, allowing you to do chown by saving the POSIX UID and GID, the owner information in the special SID as well, not just the mode bits. And then that last piece of the POSIX extensions. So what about security improvements? So back to Jeremy's question. Have we done investigations on moving the Linux kernel client to Quick? Yes. So I did some quick experiments with a couple security features. I was testing a little bit of AES 256, what that would look like, right? It's very easy to choose new encryption algorithms. I think that's something that was brought up in talks at storage conferences recently for SMB. So that looks like it's not going to be too bad. Part of these security changes, though, is improving the Kerberos scenarios, improving these cases, maybe leveraging Dave Howell's new mount API. I have a meeting with him later today. Dave and Jeff Layton and I will talk about some of this. But one of the biggest problems we have is this horrible port 445 problem. So I'm sitting at home, you can see my office here, right, with books and too many computers. And when I upgraded my internet connection, Time Warner, now Spectrum, took away support for port 445. Seems crazy, right? How could I have my connection upgraded and they turned off support for 445? Well, if we were using Quick, we wouldn't have this problem, right? So I think you guys have seen presentations at Storage Developer Conference and others about Windows support for Quick and some of the examples of what that might be. But the problem I'm seeing in Linux, and I would love any feedback on this, how are we going to get Quick drivers in the kernel? Right now, Quick is a user space set of drivers. From the point of view of the protocol negotiation, it doesn't look very bad. But from the point of view of how the heck can we get Linux guys to wake up and put Quick in the kernel, we've had discussions about forget encryption. Quick may be useful for other things, right? Quick has advantages over TCP in some ways. Okay, so other security improvements, and I'll get back to Bjorn's question in a minute. So one of the things that Shyam, one of the guys on my team, has been looking at has been improving the multi-user mount experience, win-bind integration, that sort of thing. And how do you tie, we want win-bind or SSSD to take care of most of the things relating to Kerberos ID mapping, ticket refresh, these kinds of things, but we don't want the kernel driver to have to worry about this. We want Samba user space code to be able to deal with the nuances of how to figure out what ID, what UID somebody is, what when a ticket needs to be refreshed, that kind of thing. But the user experience is pretty bad right now. There was some good work that was done by Jeff and then later by Sachin, but we need to improve this user experience. And that's something Shyam's been working about. So any ideas on that, on how to kind of make it easier to integrate multi-user Kerberos complex mounts with win-bind and make it more usable for the user. So the Linux kernel client doesn't have to know anything really about how the service is configured to figure out who you are. The service is configured to know when to refresh tickets. Basically, the kernel client and Samba on the server end are just pass-throughs for SP-nego. Okay, so let's get back to Bjorn's question. So his question was, for SMB to be usable as a generic file system, permissions need to be manageable natively. So for example, get cifsacl is not an option for backup tools. And that means that we need rich ACLs. Now, ironically, he says NFS ACLs. Well, NFS4 ACLs or NFS4.1 ACLs are based on cifsacls. And I think we all violently agree that that the POSIX ACLs, I put POSIX in quotes, right, because there was no POSIX standard for ACLs. The POSIX ACLs that Linux supports are insufficient. So NFS ACLs are based on SMB ACLs and often called rich ACLs. And ironically, Linux is the only operating system that lacks that support. So, will major distros, will they have to patch rich ACLs? Well, I'm sure distros have done this. It's an interesting question, like how do we want to do this? So what obviously today I have, much like rich ACLs, I have an xadder, a pseudo xadder that you can use to manage these. And I think the worst scenario would be that NFS and SMB and file systems that support rich ACLs all have their own private interfaces for this. And so did I look into adding support of rich ACL implementation of Andreas Grunbacher, or look into interoperation with the management tools of rich ACLs? So maybe use the exact same xadders to reveal the ACLs. I think that's a good point. So the action I take from this is the xadder that's used for rich ACLs, let's at least make sure that the cifs module supports that. So when somebody who maybe has a rich ACL tool from Andreas's old tree, it would actually work over an SMB mount. It might be possible to do. And by the way, as Jeremy says, it's terrible if all server vendors, if all file systems have their own interfaces for ACLs. And fortunately, Samba does have at least some code to deal with rich ACLs. And I think if we do have a way of using the exact same xadder that would allow Samba to run over, for argument's sake, a cifs mount or an SMB3 mount, there are weird cases where that might be helpful. But more importantly, it might cause pressure on other file systems to do the same thing. Okay, so Tom Talpi asked a question about multi-channel. Does SMB Direct also do multi-channel? And I think I have not experimented with RDMA and multi-channel enough. That is one of the things on my to-do list, but I've held that up a little bit because there were a couple concerns brought up about Aurelion's patch series. I think it looks mergeable now, but what ended up, I think we can defer working on some of this, but it looks like the more important problem to investigate first with the multi-channel series is reconnect. It looks like reconnect is missing some code in the multi-channel series patch series, that stuff that Pavel pointed out on the mailing list. But I do want to investigate SMB direct and multi-channel because I think we're going to see even better improvement with that. Most of my focus has been testing with single adapters, high perform, very fast in Azure. And as I think I mentioned, I was seeing like 1.9 improvement for 2, 2.8 for 3, 3.7 for 4, and then the performance increase starts dropping off a little bit. Okay.
That's all the time we have left for now.
Okay. There were some great questions, and I appreciate all you guys, the contributions we've had in the work, and I encourage you to look at the slides, which will have a little bit more about some of the utilities and address some of the questions that Alexander and others brought up. But please go ahead and use it. And thank you for your time on this one.